In this video, I explain about variance inflation factor, its interpretation and impact of high variance inflation factor on the dataset. So now let's start. Variance inflation factor is used to determine the presence of multicollinearity. So it represents the variance of an estimator is inflated by the presence of multicollinearity. Suppose that model is y dependent variable is equal to beta naught intercept, beta 1 is the slope, x1 independent variable, or it is also called regressor, beta 2 x2 second independent variable, other name is regressor, and it is also called predictors. Independent variable also called predictors, and dependent variable is called predictant, response variable, or regressant. So this is the estimator, beta 1 cap, beta 2 cap. In the presence of multicollinearity, these estimators, its variance get larger in the presence of strong multicollinearity, so its variance inflated. So when r square is the coefficient of determination, r square is coefficient of determination. This r square is the coefficient of determination. As it approaches to 1, the variance approach to infinity. How this we get this? Suppose that this is the formula of variance of inflation factor, 1 over 1 minus 1 I r square. R is the coefficient of determination, 1 over 1 minus 1. As r square is equal to 1, 1 minus 1, 0. Something over 0 is equal to infinity. So as r square approaches to 1, variance inflation factor approaches to infinity. Means in other words, we can say that as the collinearity increases among the independent variables, the variance of an estimator increases. Its variance of estimator increases, and its limit can be infinite with the increase of collinearity. So this is the mathematical formula of variance inflation factor. VIF is equal to 1 over 1 minus r square. R square is the coefficient of determination. Interpretation: if VIF is equal to 1 means no multicollinearity. When VIF is equal to 1, VIF range 1 to 5, low multicollinearity. Greater than 5 represents high multicollinearity, and it is problematic, and we need to remove or address such type of multicollinearity. VIF greater than 10, severe multicollinearity, and this type of multicollinearity requires immediate effect. Impact of high variance inflation factor. When you got high variance inflation factor, it means there is strong multicollinearity among the regressors. So large standard error, one consequence is standard error large of the regression coefficient. Regression coefficients are like beta 1. These are regression coefficients. It is also called slope coefficients, beta 2, beta 3, so on. Beta k depend upon your model what kind number of your independent variables. So reduce precision. When your standard error is large, it means reduce precision of the coefficients and difficulty to determine individual effect. In the presence of multicollinearity, we cannot find independent effect of the regressors because x1 has some resemblance with x2. So there's when we estimate y, so they both have similar observations, both have the same effect, so it is very difficult to find separate effect of x1 and x2 in the presence of high multicollinearity. If you like video, then click on like button and subscribe my channel Statisticians Club. You can receive more videos about econometrics in this channel regularly, and I also made a playlist in the name of multicollinearity, where the complete videos of multicollinearity available in that playlist. So please watch if you want to know other topics of multicollinearity, like concept of multicollinearity, types of multicollinearity, its mathematical proofs. So please see a playlist in the name of multicollinearity in Statisticians Club. Thanks for watching.